Good morning, everyone. Today I'm going to present on neural networks, one of an important topic in machine learning. So this presentation covers basic concepts like perceptron, MLP, activation functions, and advanced topics like regularization and deep learning. First, we are going to see about perceptron. So, the perceptron is the simplest neural network used for binary classification problems like yes or no or pass or fail. It learns a linear decision boundary to separate two classes. So, it has two inputs, that is, it is taken as x1, x2, and weights w1, w2, bias, summation. Summation will be given to activation and then it will be converted into an output. So inputs are multiplied with weights, added with bias, passed through activation and produce output. So let's see a real-time example for perceptron. Here inputs are study hours and attendance. If both are high, student passes, otherwise fails. So two inputs passes through the perceptron and output will be either pass or fail. So this shows how perceptron creates a decision boundary. So this is a single layer perceptron. A single layer perceptron has no hidden layer. It can only solve linear problems. That is input layer and output layer, no hidden layer. Only one layer of weights, simple but limited. So it is simple, fast, requires less memory and works well for linear data. So these are all the advantages of single layer perceptron. So it is simple, fast, requires less memory and works well for linear data. And these are all the disadvantages of single layer perceptron. It cannot solve non-linear problems like XOR and has limited learning capability. That is, XOR points not linearly separable. So this is a multi-layer perceptron. Multi-layer perceptron contains input layer, hidden layers and output layers. It can solve complex nonlinear problems, that is input layer, then hidden layer and then output, that is multiple layers. So hidden layers helps learn complex patterns. So input passes through layers, error is calculated and weights are updated using back propagation method. So input is given to the hidden layer and then output is generated and then error is identified through back propagation method. So these are all the advantages and disadvantages of MLP. So MLP can solve non-linear problem. It gives high accuracy but requires more data and computation. Next one is activation functions. Activation function decides whether a neuron should activate or not. That is input, weighted sum is added and then activation function is created and then output is generated. It maps the input to the output in the neural network. Whether neuron fires or not will be decided using this activation functions. So normalized outputs will be either 0 to 1 or -1 to 1. Let's see a real-time example here. Student marks prediction. Suppose we want to predict final marks based on internal marks. That is, internal marks are given here. Based on the internal marks, output, that is final marks, are generated. If output is directly proportional to input, we use linear activation function. So next one is identity or activation function. So identity function simply returns input as output. It is a straight line that passes through the data. So imagine if we are predicting a house price, the input features will be size of house, number of rooms, location. So this model processes these inputs and gives an output like predicted prices, this much given in the diagram. Next one is sigmoid function. Sigmoid function converts values between zeros and ones, useful for probability. That is, it is an S-shaped curve. For example, in medical prediction for disease probability, this sigmoid function is used. Next one is gradient descent. Gradient descent means error by adjusting weights step by step. That is, it is a curve, that is a loss function with downward arrows. It moves towards minimum error. Next one is back propagation, that is error back propagation. So it sends the error backward and updates the weights, that is forward error will be given to backward errors. It works as a backward manner. So next one is shallow network. A shallow network has only one hidden layer, that is input, one hidden layer and output. So for example, let's see a real time example here. Similarly, a student pass fail prediction. So it predicts whether a student is pass or fail. So study hours, based on the study hours, attendance and internal marks, data goes into the hidden layer. Hidden layer learns the patterns and predicts the output as either 1 or 0, that is pass or fail. Next one is deep neural network. A deep neural network has multiple hidden layers and learns complex features. That is, input is given to multiple hidden layers and it produces the output. So there are two types of deep neural network. One is TensorFlow and second one is Keras. TensorFlow is used to build models, but Keras provides an easy interface. Next one is vanishing gradient problem. Gradients become very small in deep networks. So early layers stop learning. Deep network with fading gradients. Next one is RELU, that is normalization. In normalization, it is given as batch normalization. So some examples, that is based on the common data values, the data range, it contributes the model. That is based on the it will fix a range for age or salary. Likewise, here is an example given na? So age is equal to 20 to 60, that is for working people the age will be from 20 to 60 and salary will be 10,000 to 1 lakh. Likewise, it fixes the range, that is called as scaling data values. So batch normalization is, it is a technique used in deep neural networks. It normalizes the inputs, that is it takes a mini batch of data, it computes the mean and variance and then normalize the data and then pass to the next layer. Next one is regularization. And in batch normalization, it normalizes data inside network to improve speed and stability. So it prevents. Next one is regularization. It prevents overfitting. Overfitting versus good fit graph. That is, overfitting means the model performs very well on training data, but performs poorly on new data. That is, if a new test data is given, the model couldn't work clearly. That condition is called as overfitting. Okay, there are four types of regularization. First one is L1 regularization, second one is L2 regularization, third one is dropout and fourth one is drop connect. So L1 regularization makes some weights zero feature selection, that is it is known as least absolute shrinkage and selection operator. L1 regularization technique is the adds a penalty to the sum of absolute values of weights, that is to reduce the overfitting. It creates a simple model. L2 regularization reduces weight size but not zero. L1 makes some weights as zero. Some weights will be made as zero in L1 regularization, but L2 regularization reduces the weight but not to zero. Okay. Next one is dropout. So dropout is a technique, that is it randomly turns off some neurons during training. Neural network with some nodes crossed out. That is it will randomly turn off some nodes in the neural network, that is called as dropout. And drop connect is it removes connections instead of neurons. It will not off the, that is turn off the neurons, it will simply remove the connections. So edges removed between nodes. So thank you, that's all about the neural network topic.